Alright guys, so today we're going 1.4a translations. You can kind of skip the warm-up, but I mean if you have time at the end, then definitely feel free to take out last night's homework and then check those answers with the person next to you. But what you want to do is start out by taking colored pencils if you have them. If you don't, use pen and pencil. Not so much this lesson, but you'll definitely need them more next lesson too. So if you don't have them, hopefully you have something that has different colors so you can keep yourself organized. What you should get in the corner of the room, the front corner where I usually am, this classwork. So it says 1.48 translations. It's really just blank. You just have a few graphs, and that's really what you want for your notes today. So have that in front of you. If you need to pause the video and go get one, then do that, and then come back and start it back up. So what we're doing today is looking at all of the parent functions, and then we're just translating them, either left and right or up and down or both. So we're not reflecting like we did last class. Last class was all reflecting and symmetries, reflecting over the x-axis and the y-axis. Those are the big two. But today we're just doing what we call, vertical shifts or translations and horizontal shifts or translations. So if you remember, the first parent function that we had was called the constant function. It was just some line. It was a horizontal line. And that's what we're going to kind of start with today. So we have f of x equals c, and c is just some number. So you're going to have automatically a horizontal line. We'll say it's, right at 4. So if I draw it right, that's right at 4. So that's just one example of one. I just picked 4 randomly. So if I take 4 and then I add 3 to it, right? So that would be this part right here, taking care of the 3. I don't know why that's not circling, but whatever. Basically what that's saying is I'm taking my f of x equals 4 equation, which is the black one here, and I'm just going to vertically shift it up 3. And that's what the plus 3 does. I know you're going to say 4 plus 3 is 7, just graph y equals 7. But think about how the original was just 4, and then we add 3 and moves up 3. So then if I subtract 7 from the 4, right, I'm going to take my original one, which is the black one, and then shift it down 1, 2, 3, 4, 5, 6, 7. And I'm going to have my horizontal line right there. Right, and I know you could just say, well, 4 minus 7 is negative 3, so just graph that. But think about what's happening to the original function and then how it's changing because of the plus 3 or minus 7. So that plus 3 at the end and the minus 7 at the end of the equation just mean you're going up and down, right? So plus 3 is up 3, minus 7 is down 7. You don't work a whole lot with these ones. It's more with the other functions, but it still works with these. Now the second one was the identity function, which hopefully remembers f of x equals x, which is just a diagonal line like that. So if I take x and I subtract 2, right, that really could mean two different things. Here we're just going to treat it like the last one and say minus 2 means it's going to shift down 2. So this graph, I'm just literally going to shift it so that it's down 2. Right, and it's the same exact graph. I shifted it down maybe like 2.5, but you kind of get the idea of what I was trying to do, right? So that's probably better, right? So that's my same graph. It's just shifted down 2, so the y-intercept's down 2, but everything else is the same. They should be parallel. Now what we're going to start talking about is what if I make this in parentheses here? So this minus 2 is now inside of a parenthesis. Well, now the minus sign means right 2. But if you take a look at the blue one, if you had the black one to start with, and then you decided that you were going to shift it over to the right 2, it would still be the same thing. So in this case with the line, down 2 is the same thing as to the right 2. So that x minus 2, you might think plus 2 would mean right 2. It actually means left 2 if it's plus. But, you kind of get the same thing with this one, a little bit different than the ones coming up. Down 2 is the same thing as right 2, only with a line, right? This is going to be totally different when we get to the other ones. And then throughout the lesson, just think how our domain range in 0 is changing, right? If you shift it, down 2, right? And this last one, the 0 is x equals 2, right? Right there, you can see you'd have clearly a 0 right there at x equals 2. That looks like 3. Oh, no, that's 2. But the first one, it was obviously at, x equals 0, right at the origin. So your zeros change, domain and range is the same. You got negative infinity to infinity for both. All right, so next type of function that we're going to start working with is the absolute value, right? So if you remember the original, which I'll do in black, is basically just a V shape, right? It's kind of going, we'll just go this far, and right at the origin, and then same thing, right? That's a rough sketch of the absolute value. And if you wanted to do a chart over here and say, okay, well, you have your x's, and you have your y's, and you're going to make a chart, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, right? Make a chart with 5 points. You can do that too, but I think we should be familiar with what the parent function looks like. So then if I say plus 4 inside the bars, right? This is the key here. You're inside the bars. That actually means left 2, right? Again, you might think plus 4 means to the right 2. It doesn't. It means left 2. It's kind of opposite of what your common sense is telling you. So literally all that it means is that you could literally take this graph, right, and shift it to the left 4, right, and get the same graph. Now I'm just going to redraw it, but that's literally all that it means. So I'll draw it in red, right? It's the same graph, but it's just being shifted to the left 4. So domain, range, and zeros, right? Domain is the same, range is the same, 0 to infinity. But your 0 is the one that's changing. Instead of being at 0, you're now at negative 4 is your 0. Now the last one is minus 2 and plus 3. So minus 2, because it's inside the bars, that means left and right. We're talking horizontally. So that means to the right 2, and then the plus 3 at the end means it's up 3. So it's your parent function, but shifted to the right 2, and then up 3, so that now the vertex is right there in your graph is something like that, right? And that's the only difference. It's almost like when we did quadratics last year, you had, a, and then x minus h minus squared, and then plus k, right? We should be kind of familiar with that from last year. The vertex was h comma k. So the graph, not just the vertex, but every single point on the graph is going to shift to the right h and then up k units. It's just not, it doesn't have to be a quadratic that follows these rules though. Every parent function follows the same rules. If you're working inside the parentheses, or in this case, inside the absolute values, and the next one inside the square root, right, inside the greatest integer bars, it always means to the right or left, and then outside always means up and down. So even though this is definitely just for a quadratic because it's squared, all the parent functions kind of follow that same exact thing where if you're inside, denominators, square roots, bars, it's left and right. Outside means up and down. So it's not just quadratics that kind of do that. All right, so the next one, square roots. If I have the square root of x, right, you can have a few points here. You're going to have 0, 0. You're going to have 1, 1. You're going to have 4, 2. And you're going to have 9, comma 3. Right? Those are just points on the square root of x. And again, if you wanted to, you certainly could do your own little chart over here. And then just say, okay, well, if I plugged in 0, I get 0. If I plug in 1, I get 1. If I plug in 4, I get 2. And 9, 3. Right? Those are just 4 points for the square root of x. In case you don't, I went too fast there. You can certainly make your own charts and then just fill them in, right? So this second one, I have the square root of x inside, and then on the outside I have plus 3, right? So plus 3 just means literally I'm taking all of these points and I'm adding 3 points. So I'm just shifting all of the points. Right? It's not just where a graph starts. Every single thing is going to go up 3 units. And that's my new graph, right? So the domain's the same. It's still 0 to infinity. But the range now has shifted up. Originally, the green one is 0 to infinity for the range. Now the red one, the lowest point is 3. So now I'm 3 to infinity. inclusive. And then the zeros, the green one had x equals 0. The origin was 1. The red one, there's no zeros. There's no x-intercepts in that graph, so you don't have any. So that's kind of how you do these things changing. If you wanted to work with the table, just add 3, right, to all of these y coordinates, and then you get them in your chart too. That's what the plus 3 kind of means, right? 0 plus 3 is 3. So you had 0, comma 3. 1 instead of 1, 1, now you have 1, 4. Right? Instead of 4, 2, now you have 4, 5. Instead of 9, 3, now you got 9, 6. Right? So you can do it on the chart too. I just don't, but we'll start working with charts next lesson. So you can probably tell by the last one, if you want to pause the video and just try it and then resume the video, we'll pick it back up. All right, so this last one, we have x plus 7 plus 1.5. So hopefully we kind of get the idea by now. Plus 7 means actually left 7, and then plus 1.5 means up 1.5. So I'm going to look at this green one and just shift it to the left 7, and then up 1.5. So it should be like right about there. Right, and it's not just the same for the starting. All of the points are at left 7. So this one right here, right, that's going to go left 7, up 1.5, just like there. Right, this one right here, same thing. Each of my points is going to go left 7, 1, 2, 3, 4, 5, 6, 7, up 1.5, right there. Right, and then I'll just do this last one. Left 7 would be at 2. And then up 1.5, somewhere like right around there. And that's your graph, right? So it is that easy. Again, if you wanted to work with the chart, just subtract 7 from all of your x's. So then your first point would be, negative 7. Next one would be negative 6, and so on and so forth. And then add 1.5 to the y. So, you get, instead of 0, you get 1.5. But I think it's easier if you just pick the graph up and move it. And again, domain range in zeros, right? That last one, your domain now starts at negative 7 to infinity. The range is now 1.5 to infinity, and there are no zeros. So, right, these things, all of these domain ranges in zeros are changing when you do these translations. So it's always good to kind of remember that. All right, next one, we have our quadratic function, right? So we have, a few points here. I'll just give you the negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. And there's our parent. So if I had this x squared plus 3.79, right, that's up. That's on the outside. You can take a look at the one after it. That minus 4, that's when you're going left and right. So if it's inside the parentheses, left and right. If you don't see parentheses like this one, that just means it's definitely going to be up and down. But in order to be left and right, whatever number you're adding or subtracting also has to be squared. If it's just x being squared, or like well, actually just x being squared, then you're talking about up and down. So here, the red one, literally all of the graph, not just the vertex, all of the points are being shifted up, 3.79, right? So you're going to have this, 1, 2, 3, 3.79, 3.79, right? And that's the new one. And it's the exact same thing. Again, domain is still the same, negative infinity to infinity. But now the range, the low point is 3.79 to infinity instead of 0 to infinity. Zeros, there are none anymore because you shifted it up. Right, and then this last one, x minus 4 minus 1. Again, I want you to kind of try that on your own. And then when you're done, you can start the video back up. All right, so we got minus 4 minus 1. So that means to the right 4 and down 1. So that's the new vertex. And you can get all of the points that you graphed are down 1 to the right 4. So they should be something like that, right? And now when you look at the zeros, because it shifted down, you got 2 of them instead of just this one, right? The blue one had 1 right at the origin, but you can see the green one now has 2 zeros at 3 and 5, right? So that definitely changed. Domain is still the same. Your range also changed. It's negative 1 to infinity now, right? And cubic function, x to the third, some points you'd want to have for here is negative 2, negative 8. -1, -1, 0, 0, 1, 1, and 2, comma 8. Right, so when we graph that, that's the shape. Right, that's the one that has origin symmetry. You flip it upside down, it's the same. So this plus 3.5, because it's inside the parentheses, that means you're going to go to the left 3.5. So all of these points are going left 3.5. And then up here, we're going to go left 3.5. And then down here, 1, 2, 3.5. Right? And that's it. That's the new red one. And this last one, we have -4, so to the right 4, and then +6, so up 6. Again, you can pause the video and do this one on your own, and then go from there. So we got right 4, up 6. I'm not really sure what just happened. All right, let's try that again. Right 4, up 6. Something like right there, right there, right there. This one right here. 1, 2, 3, 4, 1, 2, 3, 4, 5. That one fell off a little bit. And then the bottom one to the right, 4 up, 6 right there. Right. Now in these ones, the only thing that's changing is your zeros. The domain is still negative infinity to infinity, and range is still negative infinity to infinity, right? You're going left and right forever and up and down forever. But the zeros would change, right? So in this case, to solve this one's zeros, this is one of the ones where you're actually going to have to use some math, right? But it's the same steps. You're going to set y equal to 0 and solve it from there, right? So if you wanted to subtract 6, you would get -6 equals x minus 4 to the third. And then what you would do is just take the third root at this point of both sides. And that's not an imaginary number. Remember, only imaginary numbers only happen with square roots. So it's literally going to be, you can pull the negative right out, or you can leave it in, it doesn't matter. But it's going to be negative third root 6 equals x minus 4. And then your final answer is going to be 4 minus third root 6 equals x. Right, and that's actually literally that's point right in your graph. If we scroll back up, right, that point right there, that's, well, I kind of missed it, but you get the idea. That x-intercept is literally the point, you know, 4 plus or 4 minus third root 6, right? That's the number you would get when you did on your graphing calculator. But you wouldn't need to, right? We can do it algebraically. All right. So we have our last two. We have the reciprocal function, which is 1 over x. Looks like it got cut off there. And this is one you probably want to use a chart with. So if we wanted to do x's and y's, right? And this is a good one to get in the habit of doing a chart with, right? The reciprocal function is 1 over x. So if I plug in like -2, I get 1 over -2, which is -1 half. If I plug in -1, I get 1 over -1, which is the same thing as -1. If I plug in 1 half, or -1 half, I get 1 divided by -1 half, right? So instead of dividing by 1 half, multiply by 2, same thing as a reciprocal. So you actually get -2. If I plug in +1 half, I get +2. If I plug in +1, I get 1 over 1, which is 1. If I plug in +2, I get 1 over 2, which is 1 half. Right, so these points are good. You know, these are a good 6 points. We're going to definitely use them a lot tomorrow. So those are this is just the parent function. We're going to plug these ones in. So -2, -1 half, negative 1, negative 1, negative 1/2, negative 2, 1/2, 2, 1, 1, and 2, 1/2, right? So what we see are, there's a graph like that. There's two pieces to it. Again, you have, I'll draw these in there really quick. You have a vertical asymptote and a horizontal asymptote right there, right? So that's what the graph kind of looks like. So now, how do we want to think of these translations, right? Well, the first one, it's plus 2, but it's in the denominator. It's almost like it was in the brackets, in the square roots, in the parentheses. In the denominator means left and right. So this plus 2 means you're picking up all of these points and you're moving them over to the left 2. So it might be kind of harder to see here, but this first point to the left 2, negative 1 to the left 2, and negative 1/2 is going to go to the left 2 right there. So now this is kind of that bottom part. And then these points to the left 2, and left 2, right? And that's kind of the second part of the graph. So what happened? Well, it actually moved the horizontal asymptote, your vertical asymptote, left 2, which kind of doesn't make sense. If it's a horizontal change, you'd think the horizontal asymptote moves, but it's actually the vertical one that does. So that's what the purple one is. This last one, minus 5 and then plus 3, means you could probably figure it out, but it means you're going to go to the right 5 and up 3. So each of the blue points that we did at first is going to go to the right 5, up 3. So 1, 2, 3, 4, 5, up 1, 2, 3. So that was the first one that I had plugged in. Hold on. 1, 2, 3, 4, 5, 1, 2, 3, right there. The second one, right there at negative 1, negative 1, I'm going to move it 1, 2, 3, 4, 5, up 1, 2, 3. And then this last one, 1, 2, 3, 4, 5, 1, 2, 3. So that's the graph we're going to get with this part. And the other part, the upper right part, we're going to move this one right here up, or to the right 5. 1, 2, 3, 4, 5, up 1, 2, 3. This one, 1, 2, 3, 4, 5, 1, 2, 3. And this last one, 1, 2, 3, 4, 5, 1, 2, 3. All right, so that's the new graph right there. Right, and actually what you see is basically that minus 5 means you moved, I'll do it in green, we moved the vertical asymptote to the right 5, and we moved the horizontal asymptote up 3. And that's kind of the new graph that we get. Obviously, domain is changing, right? From that first one, you couldn't have x equals 0. The second one, you can't have x equal to negative 2. The last one, you can't have x equal to 5. You can see it on the graph. Those are your vertical asymptotes. But you can also just tell by looking at the equation that you couldn't plug those numbers in because you get 0 in the denominator. And then the range of the first two are the same, right? They have the same horizontal asymptote. That last one, the range is going to be everything except for 3, right? Because that's kind of where your graph starts to get closer and closer to that horizontal line. And how does that work? Well, it's because of this plus 3. You're never going to get an answer of 3 in the y because you're going to give it 0 for this, which means when you never get 0 and you add 3 to it, you're never going to get 3. Zeros do change, especially that last one. Again, kind of the same way we did it before. You could just basically set it equal to 0 and solve the equation, which I'll do. We'll do it really quick. Do it in black. Right, so if I wanted to find the zeros of this one, right, you should be able to tell by looking at the graph, right, this was the red one. Right, you definitely do have a 0. It's right there. There's your x-intercept. So how do you find it? Well, again, just set the equation equal to 0 if it's hard to tell by looking at it. Right, so if we want to do that, we could subtract 3 from both sides. And then we get negative 3 equals 1 over x minus 5. And we can multiply, this minus 3 is not in the numerator. Then we can multiply both sides by the x minus 5 to get it out of the denominator. And so on the left side, we'll have negative 3 times both of those when you distribute them. So you have negative 3x, and then negative 3 times negative 5 is going to give you actually plus 15. And on the right side, we're only left with 1 because these canceled out. That's why we did it. So, we'll subtract the 15 so that we get negative 3x equals, there we go, negative 14. And finally, we will divide by negative 3. So we get x equals 14 thirds. Right, and that would be our final answer. And you'd want to check the graph, make sure it looks like it's at 14 thirds, which is the same thing as 4 2/3, which does it look like it's there? Yeah, that looks like it's pretty close to 4 2/3, so you're good. So that's kind of the big ones we just covered. The greatest integer, if you remember, like the greatest integer less than or equal to 0 was 0, right? And then it goes like up to 0.9999 repeating and open, right? It was kind of this weird shape where it always went close to open, close to open. I'll do one down here, close to open, right? That was more or less the shape. And then so if you kind of had this, this is as extreme probably as you would get with this graph. If you had the minus 1.8, right, all that's saying is that the graph, each point, each little segment is going to move down, 1.8. So it's going to be, a whole bunch of these ones kind of right there, at the 0.8s or something like that. And that's kind of all you'd have to worry about with those ones. So that's more or less it. Those are called translations. Again, always think about how domain range and zeros are changing as you kind of move the graph around left and right or up and down. And then your homework is just this. It's actually not too many problems. And they should go by quick, right? I just want you to be able to look at the equation and say, this is how the graph is moving. This is how the domain range and zeros change. Without using your graphing calculator, right? Just if you want to use a chart and just add, if it's up 3, add 3 to the y's. If it's left 3, subtract 3 from the x's and do the chart that way. But I don't think you need to yet. I think you can just worry about picking the graph up and moving it. And you guys should be okay. So that's it for the classwork. You guys can start the homework if you have time. Certainly email me if you have any questions. But that's it.